I can explain how 2 points on the same line have the same slope, and I can use an algebraic rule to represent the translation, reflection, rotation of a figure on a coordinate plane. I can also explain that rotations, reflections, and translations generate congruent figures, but dilations do not, because dilations change the size. All right? So we are on STAAR review number 6. Okay, so let's start out with similar triangles. Similar triangles, any two triangles that their hypotenuses, now remember, that means they have to be right triangles, right? And the hypotenuse is always the longest side or the diagonal side. Okay, that their hypotenuses lie on the same side, same line, and have the same slope regardless of size. So they'll always be represented to you like this, or sometimes one of the triangles is on this side and one's on that side. They'll always be different sizes. It says triangles PQR and RST are similar right triangles, meaning they have the same slope. Similar is the same size, but not the same, similar is the same shape, but not the same size. Which proportion can be used to show that the slope of PR is equal to the slope of RT? So I'm going to tell you right now that PR will always be on this side because they said it first. RT will always be on this side because they said it second. So my suggestion is that you look at here and you look at PR first, and usually there's a lot more room to work. So I usually do PR on this side of my graph. I'm going to do it right here for now. PR. And I'm going to say rise over run. And remember, anytime I'm counting rise over run on a graph, I need to know what are the intervals and is this a negative or positive slope. So PR means they're wanting to know the slope of this line right here between PR. So I have a way to do that. I'm going to count rise over run, and it is definitely negative, and my intervals are going by ones. So I'm going to put a negative sign and a line. And I'm going to count my rise first, which is always going up. 1, 2, 3, 4. So I'm going to write that on top. And then I'm going to count across, which is my run. 1, 2, 3. And I'm telling you, the biggest mistake you make is you write your run over your rise. So please write it as you go. Then I am going to look at this one. Okay? So this is RT, and normally I would write PR on this side of my graph because there's always lots of room, and then I write RT on this side of my graph, okay? But for today, I'm going to write RT right here. I'm going to write rise over run, and I know that if this one was negative, this one has to be negative because they're on the same line, okay? So I'm going to count my rise, which is 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to put it on top with a negative sign. Doesn't matter, the negative can be on the bottom or the top. And then I'm going to do my run. 1, 2, 3, 4, 5, 6. So my run is 6. So for PR, I need a negative 4 over 3, and this is getting really crowded now. RT, I need a negative 8 over 6. Okay? So the first thing I'm going to do, and these always look complicated, but they are so easy, because you guys know how to count slope. Okay? So I'm just going to come over here, and you have to put it exactly like you see it in the calculator. Unless you do alpha F1, then you can put it all in at the same time. But this is what I need you to do. 3 subtract, and you don't even have to put the parentheses. Negative 4, hit enter, and I get positive 7. Now, my question for you, is there any way a 7 is going to become 4? No. So I'm not even going to go and count any more of that, okay? Let's go here. Negative 4 subtract negative 7. And I get 3. Is there any way a 3 is going to turn into a 4? No. So I know it can't be that one. So that's what I'm saying. These are easy. Yeah, they look complicated. Yeah, there's some steps to them, but they really are easy. Negative 4 subtract negative 3. And I get negative 1. Is there any way a negative 1 could be a negative 4? No, so it can't be that one. 3 subtract 7. I get negative 4. I'm going to check it because maybe I made a mistake up above somehow putting it in my calculator. Remember, this is a one-shot deal. You only get one chance at every question, and every question is going to count. So I get negative 4 over 3. Now, sometimes there's more than one that will be equal to it. So once you have found the one that is this side is equal to PR, then I need to check the RT just to make sure that it is the same. So I'm going to do negative 5 subtract 3, and I get negative 8 over 2 subtract negative 4, and I get 6. So yes, it does match all the way through, so J is my answer. The other thing that I want to remind you, sometimes when it's a positive, they will give it to you as a negative form. So this has nothing to do with this question, but if I needed positive 7 over 8, sometimes they could give it to me as negative 7 over negative 8, because a negative divided by a negative would give me a positive 7 over 8. So be wary of that. You have to be careful. Okay? All right, the last topic, well, we have 2 more topics, but we're going to talk about transformations. Okay? A transformation is a type of movement or change across the coordinate grid. Okay? We have 3 types of transformations. We have translations, reflections, rotations, okay? A translation slides a point or a figure. So in other words, it slides it. Let's say I have this square here, and I slide it to the right and then down. I still have the same size, same shape square, okay? So what your rule is always going to look like is it's going to have a plus and a minus sign, okay? Or a plus and a plus sign, or a minus and a minus sign. And on your X, because your X-axis only moves horizontally, your X is only going to move left or right. So if it's an X plus, whatever number it is, it's moving right. If it's an X minus, it's moving left. Your Y, on your Y-axis, it only moves up or down. So that means that Y plus is moving up, Y minus is moving down. So transformations, all they do is slide a figure on the coordinate plane. Okay? Over. Reflections. They flip a figure or a point over the axis. Okay? And they can flip it over X-axis or over the Y-axis. If you reflect over the X-axis, you change the sign of Y, and that's what that means right there. It doesn't mean that it becomes a negative. It means that you are changing the sign of Y. If you reflect over the Y-axis, it means change the sign of X. So it's just the opposite. Reflect over Y, change the sign of X. Reflect over X, change the sign of Y. And you're just flipping your figure. You are not changing the size or the shape, okay? You do not change the size or the shape. All right? So this little sign means change the sign. It doesn't mean make it negative for transformations, okay? Rotations is a turn about the origin. You can go counterclockwise or clockwise. And I know most of you are going to use this today to do rotation. So all you're doing is turning a figure, okay? With rotations, there are quite a few of you that I'm going to start grilling and drilling you to write this out. And I'm going to have you do it almost daily coming up here, all right? So what I want you to do is to be able to say counterclockwise and clockwise, okay? And I want you to be able to say, okay, if it's 180 degrees, it's 180 degrees here. It's halfway, okay? You're going through two. So that means you are going to change the sign of X, change the sign of Y, okay? So then I do this. I flip my X and my Y and change the sign on Y, and that is 90. It's 270 over here. Then it's Y, change the sign of X, and that is 270 and 90. And here, 360, you just go right back to X and Y because you go right back to the place that you started. So I always start here because then I remember how to do the rest of them. And I'm going to keep grilling and drilling you probably over the next few days, all right? The other thing that we need to remind ourselves is that transformations maintain congruency. So congruency is same size, same shape. Translations, reflections, and rotations always maintain congruency. The angle measures of a figure stay the same. I have always used the representation of a small square and a large square because when I say, what are the angle measures of a small square? Everybody tells me, oh, you got 90 degrees. And there are 4 90-degree angles in a small square, okay? What about if I draw a big square? What are these angle measures? Do they change? No, they're still 90 degrees, okay? So in order to keep a square looking like a square, your angle measures stay the same, okay? So we want to know, there are questions about congruency, and you need to know. The only one that changes the size is dilations. That's when you multiply by a scale factor. We're going to talk about that in a day or two, okay? So that's all I have to say. Get started on your practice. If you have any questions, please ask your teacher.